Good day, my dear students from statistics class. I'm now going to discuss about the critical region. Critical region, it is also known as rejection region, is a range of values that corresponds to the rejection of the null hypothesis. If the value of the test statistic is within the critical region, then the null hypothesis is rejected. Otherwise, the null hypothesis is not rejected. Critical values of the tests of hypotheses are the number or numbers that determine the rejection region. Thus, critical region might be a single number or an interval. For one-tailed test or directional tests, less than sign, the critical region is at the left side of the acceptance region. So H1 mu is less than the mu null. This is the acceptance region, and this one is the critical region, and this one is the z value. For one-tailed test or directional test greater than, the critical region is at the right side of the acceptance region. So H1 mu is greater than the mu null. So this is the acceptance region, and this is the critical region, and this one is the z value. For two-tailed test or non-directional test not equal to, the critical region is at the left and right sides of the acceptance region. Now this is the graph below. So this is the critical region, or these are the critical regions, and these are the critical values, and then the center is the acceptance region. For example, suppose that a normally distributed population has a standard deviation of sigma is equal to 0.12. Given a sample size n is equal to 10 and alternative hypothesis mu is greater than 10, construct the rejection region if alpha is equal to 0.05. The alpha is the level of significance. Solution. So the mean of sample means is equal to the population mean, which is equal to 10. And standard deviation of sample means is equal to the standard deviation over square root of n, which is equal to 0.12 over square root of n. So that is equal to 0.037947. Notice that the alternative hypothesis, or H1 mu, or the population mean, is greater than 10. This is one directional test. Using the standard normal table, z alpha is equal to z 0.05, which is equal to 1.645. Hence, the critical value is equal to mean, population mean, plus z alpha multiplied by the standard deviation x bar. So that is equal to 10 plus 1.645 multiplied by 0.038. That is equal to 10 plus 0.0624. That is equal to 10.0624. Now this is the acceptance region. This is the rejection or critical region, and this is the 10.0624. Another example, suppose that a normally distributed population has a standard deviation sigma, which is equal to 0.12. Given a sample size n is equal to 10, the null hypothesis mu is equal to 7. Construct the rejection region if alpha, or the level of significance, is 0.10. Solution. The mean of the sample means is equal to the population mean, which is equal to 7. And the standard deviation of the sample means is equal to the population standard deviation over square root of n, which is equal to 0.12 over square root of 10. That is equal to 0.037947. Notice that the alternative hypothesis or H1 mu is not equal to 7. This is a two-tailed test. Using the standard normal table, the z alpha over 2 is equal to z 0.10 over 2, which is equal to z 0.05, which is equal to 1.645. Hence, the critical value is computed in this way. Critical value is equal to mu minus z alpha over 2 multiplied by sigma x bar, or that is the population mean minus the z alpha over 2 value multiplied by standard deviation of sample means, and critical value is equal to population mean plus z alpha over 2 multiplied by the standard deviation of sample means. So there are two critical values. 7 minus 1.645 multiplied by 0.038, that is equal to 7 minus 0.0624 over, so that is 6.9376. And the other one is 7 plus 1.645 multiplied by 0.038, which is equal to 7 plus 0.0624, so that is 7.0624. Thank you very much for watching and listening. Please subscribe to Analyze Math for more content on mathematics.